none of these fellows can tell you what electricity is. They have no clue whatsoever. They go to school and they learn the same thing everybody else learned, in high school and in college, and that is that, electricity is, the flow of beads, what they call flow of charges, and that's the only notion they have. And if you ask them, they say, yeah, it's a flow of charges. And so where did they get this nonsense about the flow of charges? And, we've known about electricity for at least 3,000, maybe 4,000 years. People saw the lightning, and there were some fish also that, like the eel has electricity, and they discovered those. So they realized there's something there. At least they were acquainted with a phenomenon. They didn't really know what electricity was, but that's how we became acquainted with the phenomenon, right? And then about 400 years ago, approximately, we have this fellow. His name was William Gilbert. And he started looking at magnetism and electricity, and he tried to describe it as best he could for his age, right? First shot at it. And he said, the electric effluvia, the emanations, right? And he just described that differs from air, and he just went through there as best as he could. He says, just some phenomena is coming out of certain devices, right? They were playing around with static electricity at the time, and he tried to explain as best he could. And, that was approximately the start. It wasn't a very auspicious start, but again, electricity, even to this day, these people don't know, so you can't blame good old Gilbert there, right? Too much. There was another fellow, his name was Benjamin Franklin, about a century later, and he came up with this, and here, let me put him on. He used the kite, supposedly, right? And what happened was that supposedly he touched the little key there, and he got a shock. Supposedly he got a shock. I mean, that's what they say happened, but I mean, we don't know if that's the case. But this is what Franklin told people, or this is the myth, the thing that went around. Some people say it's impossible that he could have done that. Okay, whatever. Anyways, Franklin started looking at electricity. And he wasn't the only one. There were other people in England and the United States that were looking at this phenomena as well. They were trying to understand what is this electricity thingy that causes these phenomena. In fact, there were a couple of people who died because they carried out an experiment. They got a shock and they died. And so they said, whoa, this thing kills. So the word got around that electricity is to be respected. Well, by the time you get to the 19th century, you get people like Faraday, right? And he, there were others, right? But he did something interesting. He realized that if he wanted to coil around one magnet and he ran an electricity through it, the other one immediately got a electricity as well to the other coil on the other side, and it moved the magnet, right, the compass there. And so they were puzzled by this. But what's the important thing here? The important thing that we start looking, starting in at least in the 19th century, is that these people think that this happens without a mediator. In this case, we have a mediator, which is the round magnet there, but it doesn't even have to be a magnet. It could be just a piece of metal. But the point here is that the electricity supposedly goes through the coil only. And here he realized that the electricity was somehow stimulating the round metal thing that he had there, and somehow transferred that electricity to the other side. But again, it was all, the way they saw it is that it was done without a mediator. That electricity somehow seemed to flow, and that maybe you did not need a mediator to have this electricity flow. And the same thing happened with light, with the electromagnetic wave. And here you have two gentlemen. One is James Maxwell, the other one Hertz, and they worked on the wave and passed it on to our days. And what you're staring at, again, what are you looking at? Well, you're staring at a couple fields, which is a bunch of numbers in space, value at each point in space. And the fields are made out of these arrows, and the arrows are vectors. And what's a vector? Magnitude and direction. So this thingy that you're staring at is not a thingy. It's a concept. It's a mathematical concept which they illustrate, and people think they're looking at a thing called a wave. There is no such thing called a wave. You need to identify what light is made of, and they never did using this arrows and fields, you know, these images. These images are very misleading because people look at this and think they're looking at an object, and they're not. And again, one of the notions that we have today among many so-called physicists, mathematical physicists, is that light needs no medium through which to travel. And that's also misleading for two reasons. On the one hand, are they talking about, you know, the medium light goes through, or are they talking the medium of light itself? Those are two different topics. You know, are you saying that light itself does not have a medium? Or are you saying that if it goes through space, space is nothing, supposedly, and so light can go through space because it does not need a medium through which to travel? So those are two different questions, and they never clarify that very well. Okay? But anyways, by a little over close to the end of the century, the 19th century, you have these people like Perin, and he started working with the CRTs, and he was able to show that you can deflect an electron beam, electricity, with a magnet. And that was so strange for him, you know, that you could bend the beam just by putting a magnet in there. And they said, okay, so by that time, you know, what was arising was the notion that these beams were made of electrons. And what was an electron? Well, it was part of the atom. It was an electron that was somehow part of the atom. They didn't know exactly how at the time, because we're talking about 1895, thereabouts. And so they said, well, it's part of the atom. It's an electron. That's what they called it eventually. But they didn't know what it really was. They just said, look, all these are electrons. We're going to call them negative, you know. The other guys are positive. And we can bend the beam of electrons with a magnet. That was the notion, you know, that's what they discovered without understanding anything. Once again, all they did was try to describe the best they could something that was invisible and intangible. Okay, and again, when you have invisibility, you know, you could make gross errors, which is what they've done all the way to today. Okay, and here we have good old Tesla, and he came up with his Tesla coil. And he was able to get the electricity outside of the thing. In other words, you don't have to have it boxed up in a CRT tube of any kind. You know, you can have it on the outside. And it had a certain range. And good old Tesla tried to use this for, again, for practical things. He was not a scientist. He was just a tinkerer. And he was tinkering with electricity to see what he could make money, and he could make it, he could put it to some use in society. That was his only goal. He was not a scientist. A scientist is someone who explains, and good old Tesla died without being able to explain what either light or electricity are. He could not explain either one. And one of his competitors, his name was Marconi, and Marconi also misled the world because he was able to transmit signals, right, without wires, the wireless, right? And this is a serious problem because now this language reaches the public and other researchers, and they said, oh, we have a wireless transmission. And what does that mean? Well, people think that wireless means objectless. There's no mediator. That's the notion that people got into their minds, that light and even electricity and all these do not need a mediator, especially light. And so we have a problem because now these people start thinking, well, I can't see one, I can't touch, the mediator light, so there is no mediator. Such a dangerous conclusion because it's a totally irrational conclusion. No, there is a mediator for light. There is a mediator for electricity. You just need to identify what Mother Nature's using out there. And they never figured that out. They always did it with little balls, and they could not explain it with little balls, with little particles. So eventually they came to quantum mechanics, which grew out of that and called them quantum objects or mathematical objects. That's what we have today. We don't have objects. We have mathematical objects, whatever those are. Okay, and so we have these two gentlemen beginning of the 20th century. One's name is Niels Bohr, and the other one Rutherford, right? Ernst Rutherford. And they came up with this model of the atom, which is a ridiculous, irrational atom, because the electron just keeps rolling around. We don't know why it rolls around these energy levels, orbitals, whatever they want to call them. But they don't fall all the way to the electrons. They don't fall all the way to the center of the nucleus, which is positive. Should be attracting it all the way to the center. And again, the electron doesn't fly out spontaneously. So it neither flies out nor falls to the center. It just keeps rolling around the orbitals and then falling from one orbital or energy level to another, up and down. Why? This is an irrational atom. Because, see, those circles that you see there, they don't really exist. They put them there to show you that there's motion. But all you should see really is an electron bead next to a nucleus. And that makes no sense whatsoever, because you cannot explain why the electron doesn't fall to the nucleus or spontaneously fly away. Okay, so here we have the notion of electricity that came out of all these concepts that people were shuffling, right? And here you have this. This is the notion we have today. If you take electricity, you're an electrician or whatever, this is what they teach you. They say, look, it's the electron beads. They flow from one atom to another. And the flow of all these, charges? Is that what they call them? All these charges, that's electricity. And so they give you a little circuit that goes something like that, looks something like that. And once you close the circuit, you have a closed circuit. What happens? Well, at that point, you have electricity flowing. What is the electricity? The electron beads that move from one atom to another. But they're all founded, this model is based on the Rutherford Bohr model of the atom, which is an irrational atom. So this is an irrational interpretation to electricity. This is not electricity. There is no flow of electron beads. And so, yeah, again, what they talk about is concepts known as mathematical objects or quantum objects that behave a little differently than classical objects, meaning rational objects, right? And one fellow, his name was Einstein, and he was able to get a Nobel Prize for explaining the photoelectric effect. And how did he explain it? Well, he said, look, you have all these photons, these photon balls, and they hit a polished metal plate, and what you have is the electron beads of every atom, and they start flowing, and that's the flow of electricity. So again, he's explained all this with little balls and got a Nobel for it, when it's all an irrational explanation for both light and electricity. Light is not made of little balls, and neither are electrons made of little balls that go around the atom. So the whole concept that we have today that everybody learns in high school and college is totally wrong. It has nothing to do with the reality that Mother Nature runs out there. Okay, so yeah, since they did everything with wireless, without what I call objectless, there's no object, there's no mediator, and they have all these things like entanglements done with, with no mediator between the particles. They have all these irrational notions. And one of them here is for gravity from Brian Greene, and he'll tell you they don't believe that there are mediators. Why? Because they can't see or touch these mediators. So they say, well, there's nothing there because I can't see or touch them. And that's the notion they have of the word object. And here, look at what he has to say. This is how he dismisses the possibility that there's a mediator between the Earth and the moon. Listen to him.
How does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. But everyone knew that wasn't true. But everyone knew that wasn't true. But everyone knew that wasn't true.
Yeah, good old Brian Greene. Brian Greene. They dismissed it too early. They said there's nothing connecting the Earth to the moon because we can't see anything. We don't get tangled when we go in that region, so there's nothing there. Yeah, it turns out the mediators that Mother Nature uses that they never even thought about are intangible and invisible. You can't see them, you can't touch them. That doesn't mean that there is nothing, that there is no mediator there. There is one there because a mediator is that which has shape. Not all mediators can be seen or touched. Those are two irrational criteria for what a mediator is. And that's the whole thing. If they would have thought about intangibility and invisibility, then they would have hit it on the nose. They would have known why the moon doesn't run out of the solar system, because it is physically bound, every atom of the moon, physically bound to every atom on Earth. We cannot see or touch those mediators. That's the only issue. And once you get past that, you understand how this universe works, at least in a rational manner. Do you believe in it? We don't care. Inside, we don't care what you believe. We just explain so that you understand. And so that's where we have Mr. Susskind, I don't know why they pronounce it like that. I think it's correct pronunciation should be Susskind. Lenny Susskind, he's from Stanford University, and he's a big honcho in math, knows nothing about physics, and here he's going to tell you he knows absolutely nothing about physics. Why? Because today they cannot give you a physical interpretation of how this universe works. You know, quantum mechanics, what does it explain? They say they don't understand it, and they cannot explain it. So listen it from him. I mean, hear it from his own mouth. Okay, here he goes. Listen to him.
Quantum mechanics is not intuitive. Very little of modern physics is intuitive. Well, what does intuitive mean? It means the ability to think about it with basic classical physics, the physics that we evolved with, throwing stones, splashing water. Quantum physics, general relativity, quantum field theory are deeply unintuitive in that way, but rewire. And it's to the point where me and many of my friends can think more easily quantum mechanically than we can classically. We've gotten so used to it.
Yeah, that's what happened. All these people have become irrational, and they cannot explain everything in a classical way, meaning in a way that you can imagine it, can visualize it. And so they have these irrational explanations. Why? Because they were never willing to let go of the particle hypothesis. They do everything with discrete particles. You cannot explain any phenomenon of Mother Nature, especially the invisible ones, with discrete particles. And that's the whole thing. That's the whole issue. And again, they have never defined the words necessary to do physics, which again, words such as object, location, existence, motion. Those are words that are absolutely necessary that you need to define in order to explain a phenomenon in physics. And they never did. Not a single textbook of physics on planet Earth begins by defining what an object is and what existence means, when physics is the science of existence, and you can't do physics without an object. And not a single book ever, or still does, begin with the definition of those two words. So that's the situation today. We have all these so-called mathematicians who we think are very intelligent when they're actually very, very dumb people, because they have no clue whatsoever how this universe works. They never figured it out, and all they're doing today is just math on inexistent stuff. You know, like holograms, the inside of a black hole, and who knows what else. Tomorrow they'll be doing unicorns and leprechauns, for all we know. So we have the wrong people doing trying to figure out the questions that we need answered. And those are, how does this universe work? Why does it work the way it does? What are the causes? What are the mechanisms?